Hello everyone. So today we will be starting the first chapter of our physics course, that is light. So what is light? Light, we can say it is nothing but a form of energy which is responsible for our sensation of vision. That means what is light? First of all, let us write the heading. What is the light? Light is nothing but it is a form of energy. It is a form of energy. Okay, we have different forms of energy: wind, water, thermal, nuclear, etc. etc. And this is one among those. This is a form of energy which makes the object visible, which makes different objects visible. Different objects visible. Okay, so that means it is responsible for our sensation of vision. So whatever we are able to see, it is because of this form of energy which is light. So, while talking about light, we need to understand that there are certain objects which are necessary for us to see different objects. Okay, suppose there is a room and there are different objects. Suppose this is a box which is lying in a room. Okay, and in a room there is no source of light. Okay, there is no source of light. So, we will be concerned about uh, this particular thing, that is source of light, so which is mandatory for us to see different objects. Suppose this is an object. Okay, this is an object, and to see this object, if suppose this is your eye. Okay, this is your eye, and when there is no light, when there is no source of light, what will happen? There will be no light entering your eye. When there is no light entering your eye, you won't be able to see anything. So how this works is that, suppose when there is a source of light, suppose there is a source of light, there is a incandescent bulb, there is a LED, anything that is a thing which is emitting light. So when there is a source of light, when there is a source of light, what will happen? The light will be striking these objects. The light rays will be striking these objects, and as they strike this object, what will happen? It will scatter the light in different direction. It will scatter. So basically what will happen? This light will scatter, and this light when scatter, some of the light rays, what will happen, will enter your eye after striking. Then this source of light emits light, and then this light strikes the object. Then what happens? Some of the light rays will be bounced back to your eyes. These are your eyes, and what will happen? As the light enters this your eyes, you are able to see this object, you are able to see this. Okay, so this is how it works. So what is necessary for different objects to be visible is that source of light. What is necessary? Source of light. So how you are able to see the objects? You are able to see different objects when these rays of light are striking this object, and then these rays are scattered around the different directions. Some of the light rays are reaching your eyes, and which makes in turn this object visible to you. You are able to see this object. So what is necessary for this source of light? This source of light, we call it as luminous object. So we have actually classified different objects because this objects in particular is not emitting any light. So we will call this as non-luminous object. Non-luminous object. Okay, and this source of light, because it is emitting light, we will call it as luminous object. Luminous object. So what are the different objects? The objects which emit the light, which emit the light, or that means which are acting as a source of light. These are called as luminous objects. So it can be. So what can be your luminous objects? If I talk about two categories of objects, if I am putting in these, so first will be your luminous object. So luminous objects are those which are emitting the light. So which emit light. This you can say, which are emitting light, which emit light. So this is the natural ones are obviously sun, the stars, है ना? And then other are like it can be your incandescent bulb. Okay, that means your uh, your um it can be your LEDs or anything which is emitting light, which is emitting light. So this is 100% this object is should be available to see different, because these are the objects which will be uh, creating, or which will be establishing the presence of light in the surrounding. Okay, or as long as this luminous object is present, you will be able to see. As long as you turn off the light, as long as there is dark, as it becomes dark, you are not able to see anything that is luminous object. So what is second type of object? That is non-luminous. So what is non-luminous object? So non-luminous objects are those which are not emitting any light. Okay, which are not emitting any, which are not emitting light. Okay, not emitting light. So what are these? Okay, all the objects which are able to see when you turn on the light, those objects are all non-luminous objects, such as we human beings, the laptop, the chair, the table, the pen, the pencil, the anything which you are able to see when you turn this source of light on, and then you are able to see some objects. Those objects are non-luminous objects. So this is how light, you are able to see the objects in your surroundings, that is a luminous object is present. So we will be learning different phenomena with light in this chapter, and one of those is reflection. And reflection is nothing but bouncing back of light. Suppose I told you that when there is sun, suppose this is a sun and there is a certain object around here. Okay, there is a certain object is placed. Okay, and when this light is falling on this object, what happens? I told you that light is scattered. Light is scattered after this is incident on this object. Light is scattered, but some of the light, I told you that it will be reflecting back. Now see, I am using the term reflecting. So some of the light is reflected, that means it bounces back to your eyes. So these type of phenomena, this type of phenomena, that is some ray of light strikes an object and then it bounces back and reaches our eyes, this is called reflection. Okay, so what is reflection? We can write the definition of reflection also. Okay, the phenomena it is actually what? It is a phenomena of bouncing back of light, bouncing back of light, bouncing back of light, bouncing back of light after striking, a surface. Okay, after striking a surface or object. So the surface can be this, depending on this surface, the quality of reflection will be, accordingly the quality of reflection will be observed. It depends on the surface. Okay, so this surface will define the quality of your reflection. Suppose obviously when you can see always a polished surface or a shiny surface, shiny surface, what will happen if you are making light incident on these types of objects? The reflection will be, the reflection quality will be better, and you will be you can see uh, this reflection, your image sometimes on these reflective surface. Okay, suppose a mirror. So mirror is a highly shining, it is a very polished surface, it is a very highly reflective surface. So what happens? The quality of reflection is very high. And if the surface is rough, suppose rough surfaces, example is, suppose I am talking about rough surface, so that surface can be your walls. So what happens, sometimes also a very blurry kind of image can be observed on the walls when there is presence of light, but that is not a very crisp reflection, because rough surface, the quality of reflection will go down. Okay, so this is what is happening. The surface, the quality of this surface or the nature of this surface, the material of this surface will be governing your reflection, that how the reflection is going to be. Okay, so this is what is all reflection is all about. So first of all, we are studying reflection. So another phenomena is what? Refraction. It is bending of light, and these two phenomena we will be studying majorly in this course. So reflection, we will be taking reflection first of all. So if I say that a mirror is here, suppose this is a reflecting surface. Okay, I am making this dashed line, that means this is a non-reflecting side. This is your reflecting side. Suppose I am taking a mirror. Okay, this is reflecting surface. So what happens? What is reflection? Suppose there is a source of light. From source of light, this ray will be coming and strikes this surface and it will be bouncing back. It will be bouncing back. So what is that? So this is your, this one is your, this one is your reflected ray. We call this as reflected ray. So these are all terminologies. The light, the ray of light, actually we will be understanding this light in terms of ray diagram. So this is basically a very beginning of your ray diagrams. So this is you can put this in the category of ray diagram. So what is happening? This light, so this ray of light is coming from some source. From some source this light is coming, or maybe an object, okay, which is reflecting back the light from some other source. So basically that will be acting as a source. On a whole, you need to understand that there is a source of light. So somewhere indirectly or indirectly this ray of light will be coming. So before it strikes the reflecting surface, till that time period we call this till that duration, or uh, till that slot we call it as incident ray. As soon as this incident ray, because it is incident on a surface, that's why the name is incident ray. So as soon as this strikes the surface, what will happen? It will bounce back. So this bouncing back, that time this ray is called as reflected ray. So this is what we call as reflection. So this is your reflection phenomena going on. This is nothing but your reflection. So I am taking this as a plane mirror. So this is actually a plane mirror. What is a plane mirror? First of all, there are different kind of reflecting surface. Okay. So reflecting surface are of different types. So first of all, what is a plane mirror? Plane mirror means, when we call in this course, we will be again and again citing this plane mirror. So let me clarify what is the meaning of a plane mirror. So plane mirror, mirrors can be of different type. Okay, when the surface of this mirror is perfectly plane, that means perfectly plane. Perfectly plane means when you put a suppose a hand lens. Okay, suppose you zoom out, you put a hand lens over this. This will be on a microscopic level also. This will be pretty much even. This will be very perfectly plane. Okay, and this is as I told you, that dashed line is not, is the non-reflecting side of the mirror. Okay, and this is your reflecting side. So this is an example of a plane. This is a plane mirror. This is how we represent a plane mirror. That means the surface is perfectly plane. And when, suppose the surface is jagged, surface is like that, then and this is also a mirror, but we don't call it as a plane mirror. We won't be calling this as a plane mirror, because for a plane mirror this must be a perfectly plane, perfectly even surface, then only we will be calling it as a plane mirror. Okay, because for perfect reflection, then we all only a plane mirror is responsible for a perfect reflection, and that is why this plane mirror is a idealistic mirror. Okay, a perfect 100% reflective surface will be there, and that we call it as plane mirror. Okay, so this is all about plane mirror. Now what we will be learning is, this is the first actual topic, or the question from where questions can be asked, that is a reflection rules, or you can better call it as laws of reflection. Laws of reflection. See, this behavior, this reflecting back of light, this falling of incident ray on a surface, and then the reflected ray, this is all is governed by a law. Okay, so two set of rules are there to understand this. Okay, suppose this is your plane mirror, this is your reflecting surface. Okay, and I am telling that, suppose this is the incident ray. Okay, incident ray. So this is falling like this. So I am calling this as the incident ray. This is your incident ray, which is before the reflecting. Before the reflection, that ray you call it as incident ray. And after this, obviously this light will bounce back from this reflective surface, and that we will call as reflected ray. So first of all, we need to understand that two set of rules will be there. The first one, before learning these laws, you need to understand the concept of normal. So what is a normal? First of all, we will be understanding what is a normal. You need to understand this. Suppose this is a plane surface. Okay, this is a plane surface. If I ask you what is the normal to this surface, because in mathematics and science what happens is every surface is defined by a vector or by a line which is perpendicular to that surface. Suppose this is a surface. Okay, this is an area, this is a plane, this is a area. So this perpendicular to this surface, if you draw a line, that you will call it as normal of this surface, normal of this surface. So similarly, what I am telling you is that this is suppose a plane surface. So if I ask you what is the normal to this surface, so what you will do, perpendicular to this plane you will draw a line. Okay, perpendicular to this, suppose this is the perpendicular, this is 90 degree, this you will call it as normal. Suppose this is AB, so I will call this normal to surface AB, normal to surface AB. So this will be your normal, so that at any point, at different points, you can identify the normal. Suppose I ask you to find the normal at this point. How will you find the normal? Again, you will see that to this element you will be drawing the 90 degrees. So this will be the normal. At this point, this will be the normal. Okay. What I am telling is, at this particular point, at this point, this is the normal. At this point, this is the normal. That is the meaning. Okay. Suppose now I am telling, let us consider this example. Okay, because what happens is that oftentimes what happens, students are stuck in this normal. They are not able to understand, or they are not able to visualize how will be a normal drawn, because as long as there is plane surface, you are easily able to identify where is the normal. But what happens, suppose this is your surface, suppose this is the surface, this is the surface. Now this is not a plane surface, this is an uneven surface, this is an uneven surface, this is an uneven surface. So what happens in an uneven surface, again if I want to draw normal, so suppose I want to find normal at this point, so how will be finding? Now you see that this is the portion. Okay, this is the surface 290 degree, this will be the normal. Okay, so this will be making 90 degree here, so this will be the normal. Again if I ask you to find it this point, so this is your surface, and now the 90 degree to this surface will be like this, like this is 90 degree. So what happens, at different points different angles of normals are possible, as long as the surface is plane, as long as the surface is flat, it is perfectly plane, then the normal at every point will be parallel to each other. That is like this. This is your normal. This is 90 degree. This is your normal 90 degree. So you can see this is first normal. Okay. At different points you are drawing the normal. What is happening? These lines are coming parallel. That means it is easy to identify normal. What this is the case of uneven surface. So we will be learning about different types of reflection, that is uh, diffused reflection, and we have a perfect category of reflection. Okay, so diffused reflection we are having, and then we are having a perfect reflection. Okay, so reflection, when the surface is, as I told you, that depending on the surface the quality of reflection will depend. So what is happening, if this is the uneven surface, we will be not having a very crisp reflection. Okay, so this is what is the importance of surface and normal. So this is how you should discussion on our laws of reflection. So as I told you that this is the surface which I have drawn, and the dashed lines are the ones where this is the non-reflecting side and this is your reflecting side. So from some object, or say from some source, this incident ray is coming. So first of all, there are two set of laws. The first one is, I am discussing now the first one. So first of all, for that I need to draw the normal. So at this is the called the point of incident. The point where this incident ray is striking, this is called the point of incidence. This is the point of incidence. This is the point of incidence. From this point of incident, what you are supposed to do? You are supposed to draw a normal. So this is your plane. Okay. So 90 degree to this plane will be like this. Okay. This is your normal. This is your normal. This is your normal. You can see that this is the 90 degree angle and that is your normal. So what first law says that the angle between this normal and incident ray is marked by I, and this angle I is called as angle of incidence. Angle of incidence. This is your angle of incidence, and this angle of incidence will be equal to the angle of reflection, which will be the angle between the reflected ray and the normal. That is why the normal is important. Now what will happen? This reflected ray will be in such a way, this reflected ray, this is your reflected ray. This reflected ray will be such that the angle which it makes with this normal, this is the normal. Now this is also an angle, which we call it R. This is angle of reflection. So what first law says is that this angle of incidence is is equal to the angle of reflection. Okay. So it tells us that is why the normal is important, because why normal is important? It is acting as a reference point. So this angle between this incident ray and normal is called as angle of incidence, and the angle between this reflected ray and this normal is called as angle of reflection. And the first law of reflection states that this angle of incidence must be equal to the angle of reflection. So that is where the reflected ray will be emerging from the point of incidence. Once the incident ray is established and you measure the angle of incidence, and the reflected ray will be equal, the angle subtended by that reflected ray with the normal will be equal to the what is that subtended by the incident ray. Basically these two angles will be equal. The second law tells you that this incident ray, this incident ray, this incident ray, this reflected ray, this reflected ray and your normal they will lie in the same plane, lie in the same plane, in the same plane, same plane. That means suppose this is your incident ray and this will be your normal and the reflected ray will be this. That means all these incident ray, reflected ray and the normal can be drawn on a paper like that. Okay, they can't be like this. Suppose this is your incident ray is like that and reflected ray is like that. So this is not possible. According to a law of reflection, they must lie in the same plane. This is the incident ray, this is the reflected ray, and the normal also like this. It is on a same plane, it is on a single plane like this. Suppose this is, I am taking this. So what is he's telling is that this all these three will be lying on the same plane. That means all three will be aligned one over the other, not like this. If this is your incident ray, reflected ray will be in this plane only. Normal also will be like this, not like this. If incident ray is like this, then reflected ray cannot be like this. No, they will be in the same plane. That is the meaning of this second. So these are the two laws of reflection. Okay, so this is what uh, is general laws we need to keep in mind while we are drawing the reflected ray. So we can take an example to understand that this concept. Suppose this is a reflecting surface, this is a plane mirror, and an incident ray is made here. I will write incident ray with abbreviation IR. Okay, this is your incident ray and this is your normal. Okay, so that is the significance. Suppose this is making 30 degree, so this will also be 30 degree. Okay, this is your reflected ray. Like this is the concept. Okay, so sometimes in questions what he will be asking is that the incident ray in numerically, how will they ask? The angle subtended, they will ask questions like this: the angle subtended by the incident ray, with the reflecting surface, suppose this is a question, reflecting surface is 30 degrees, calculate 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 the angle of reflection. What is your answer? Now we know angle of incidence is equal to angle of reflection. So what happens is sometimes student will directly answer, okay, answer will be 30 degree. No, this is wrong. Please read the question carefully. Where is he specifying what angle he is talking about? The angle subtended by the incident ray with the reflecting surface, he is telling. So if you draw the diagram, this is your non-reflecting side. Suppose this is a reflecting side. What is he telling? This is the incident ray. This is the incident ray and the angle made subtended with the reflecting surface. So this is your reflecting surface. This is your reflecting surface. This is your reflecting surface. So the reflecting surface, the angle between the reflecting surface and the incident ray is 30 degree. But the law of reflection is this, that the angle of incidence and angle of reflection should be equal. So what is angle of incidence? 30 degree is not the angle of incidence. What is the angle of incidence? This is 90 degree. This is obviously is 90 degree. So this is your normal. This is normal. So angle made by the incident ray with the normal is your angle of incidence. So what is the angle of incidence? It will be 90 minus 30 degree, which is 60 degree. So this is your angle of incidence, 60 degree. Now the reflected ray will be equal to this particular angle, which is 60 degrees. So answer will be what? Answer will be angle I is equal to angle R. So which is angle I we calculated 60. That is why the answer will be 60 degree, not 30 degree. Please read this, because this happens many times. So this we need to understand that which angle he is talking about. So this is about the laws of reflection. Okay. So now what we need to understand is that there are also different types of material. We can classify these non-luminous types of object into some different categories. So one category we call it as opaque, and one is transparent, and other is translucent. So we must know these terms, because these segregations are made based on light only. So what is an opaque? Opaque means which completely blocks light. So these are basically objects. These are all objects. So what is opaque objects? Which completely block light. Completely block light. So these will be completely blocking light. So what happens? Suppose this is a piece of brick, and light is incident on this, okay, on this piece of brick. What will happen? Light will bounce back, but it won't allow light to pass through it. So what will happen? On this side you will observe a shadow. So shadow is possible because of this opaque behavior only. What is happening? From the source of light, it will act as an hurdle. It will block the light, and the region behind this, if there is a surface behind this, what we will observe? We will observe a shadow, and this shadow is possible only in opaque objects. Perfect shadow, that means a crisp shadow we will be getting. So this is because of this opaque behavior. Some substances are transparent. That means they will allow the light to pass through them. Suppose a glass. Okay, if you talk about glass, it is transparent. It will allow the light to pass through it. Okay, however, there will be another phenomena involved, which is bending. We will be learning about it in the subsequent classes. But what we need to understand is that transparent are the objects in which light enters from one side and it penetrates the object and it comes out from the other side. That means we can see through these objects. That is transparent. And most of the materials will be somewhere between these two, and that we call as translucent object. That means they will block some of the light, they will block some of the light also, and they will pass some of the light also. So this is the intermediate behavior. So these objects are called as translucent object. Most of the objects fall in this category only. A perfect transparent and a perfect opaque objects are not that much. Only translucency will be observed. That means somewhere intermediate between this opaque behavior and transparent behavior, we will be seeing these objects. And these are most of your practical objects, because they will block some of the light and they will pass some of the light. That means some of the light will be stopped by that object, reflected by that object, and some of the light will be observed and some of the light will be passed through that object. So that is what is a translucent object is. So now we have learned about reflection and all this. Now there are types of reflection also. Okay, type of reflection basically. So this is what we will be learning, because this is important, that how an image will be formed when reflection occurs. Because always you see in mirror also you are not seeing the real you, it's an image of you. So what we call that something which is formed by that reflection, that is nothing but an image. So type of reflection, first of all, that will be two types of reflection. One is regular and the second one is irregular or diffused. Diffused or irregular reflection. So as I told you that regular reflection, these both are depending on the nature of surface. So regular reflection, if I talk about what is regular reflection is nothing but this is your surface regular, which is perfectly plain. This is a regular, means this surface is even throughout. And diffused will be somewhat like this. The surface is not regular, it is uneven. So what will happen, suppose a ray of light is incident on this surface. What will happen? This is your incident ray, and if I draw the normal somewhere 90 degree to this is your normal. Okay, what will happen? Equal to this angle, the reflected ray will be. Again, if it somewhere else incident ray is occurring on this surface, this is the point of incidence. Again, if I draw normal like this, again if I draw normal like this is 90 degree. This is your angle of incidence. So again what will happen? Again the reflected ray will be like this. Sorry. The reflected ray will be like this. It will be somewhat parallel to this. These both will be, these two lines will be parallel. These two particular side of line, you can see these will be parallel. See, you can see anytime you will, again you will, if you take like this, again it will come. So what you will observe, see here, these are your reflected rays, and what will happen? These reflected rays are regular throughout, and that is why the reflection quality will be sharp and crisp in this case. Because of this plane surface, the reflection will be very sharp, and a perfect crisp image or the crisp reflection will occur, and that we call it as regular reflection. Now consider this case. What will happen here? Suppose I am taking this point and an incident ray is striking this point. Now what will happen? I am taking this point of incidence. This is my point of incidence. So, and point of incidence, this is your normal. As I told you that you can see the small surface, this is your normal. So according to this, the normal will be somewhat like this. For this, normal will be somewhat like this. So the reflected ray, will be what? If this is the angle of incidence, this will be your angle of, this will be your reflected. Suppose I take another point. I take now this point. Suppose I am taking this point. Okay. And now what will happen? If I am taking incident, this is your surface. So normal obviously is like this here. Normal is like this. If I draw it with the blue color, because I am taking the blue color as the normal. So this is your normal. This is your normal. This is 90 degree. Now if I draw the incident ray, if this, at this point the incident ray is there, or let us take the angle similar to that case only, like this. So now if in this manner the incident ray is coming, this is your angle of incidence, and accordingly somewhere here the reflected ray will be there. This is angle of reflection. So you can see this reflected ray is there, this reflected ray is here. So these reflected rays will be not in a specific direction, they won't be parallel. So here the image will be a diffused one, that is a blurry image will be formed because of this surface, and that is why this reflection, this quality of reflection, this type of reflection is called as diffused reflection. You can see by back tracing these, this is how it is occurring. See, these are actually parallel lines, you can see that. So that is why there is a regular order of reflected rays here, and you can see that here the reflection is regular reflection. uh, Mostly these kind of surfaces are your shiny surfaces, more glossy surfaces. These are irregular, like maybe a book, the pages of a book, maybe a rough wall. So these are nothing but your diffuse or irregular reflection. So this is just for understanding. Now what happens is that now we need to understand what are object and what is image. So to understand what is an object and what is an image, we must first take a reflecting surface, and that will obviously I am taking it as plane mirror. So this is your reflecting side of the mirror. And what happens is that suppose I am taking an object, I am denoting that object by a point. So this is your object, this is your object, this point is your object, and this is your incident ray. Okay, this is incident ray coming from that object. Suppose this is your incident ray, these two are your incident rays. What happens according to the law of reflection? This angle of incidence will be equal to the angle of reflection, and accordingly the reflected ray will be observed like this. And accordingly here also the reflected rays will be observed. These are your reflected rays. Okay. Now see this. I am back tracing these rays. I am back tracing these rays. You can see that if this is your eye, if you are observing this from here, what is happening? If this is your object, so this is the general criteria of drawing ray diagrams. We take objects by a dot or by a line, depending on how you are taking. Suppose I am taking an object as a point. From that object, somewhere light source is putting on this object, and then light is reflected by that. Ultimately, this is behaving as a source. So this is incident rays are coming from here, and after this reflecting surface, this is your reflecting surface. So this reflecting surface, this incident ray is reflected, and what is happening? These reflected rays are reaching your eyes, but what your eye is observing, your it will appear to your eyes that these reflected rays are meeting somewhere behind this mirror, are meeting somewhere behind this mirror, and this is called as your image. This is your image, because this was your object, and after reflection these reflected rays will appear to come from this point. This is an image. Okay, this is what you will observe in a mirror. This is the image. Moreover, you can see that it will appear to your eye that these rays are appearing to merge or appearing to form an image. That means these reflected rays are not reflected rays. What this eye is observing is that reflected rays are not actually meeting. Actually meeting for your eye, the image is formed. We can see the image, but they are not actually meeting. Since these reflected rays are not actually meeting, that means this is a virtual meeting. These rays are virtually meeting, and that is why this kind of image we call it as virtual image. This is virtual image because what is happening? These reflected rays are appear to come from this point. From this point they are coming. It appears to our eyes that these reflected rays are coming from this point. It appears to our eyes that these reflected rays are coming from this point, which in reality is not the case. These rays are not meeting in real. So that is why this image is observed by the eye, but these rays are appear to be meeting at a point. These are rays are coming appear to come from this point, and that is why we call this as real ray. Okay. Suppose these reflected rays meet actually. Suppose if these reflected rays were actually meeting at a point and then forming an image, then we call it as real image because the the intersection of these rays exist in the real case. It is not a appearing to your eye case. In actual sense, the reflected rays will be intersecting at a point that we call it as real image. But this is a virtual image. So you can see that I took an example of a plane mirror. So always in the case of plane mirror, what will be happening? These reflected rays will not be meeting on the real side of the world. They will be meeting on the back side. They will be appear to be meeting on the back side of the mirror, and that is why we call that all the images formed by a virtual mirror, by a plane mirror, is virtual. That means the mirror which we see, our image, the plane mirror which we see, the image which we observe is not real image, it is a virtual image. So we can actually classify images into two types, that is a real image and virtual image. So virtual image is what? In which the reflected rays are actually actually meet meeting. That is why we call it as real image. But what happens in a virtual image? Just now I told you the case. The reflected rays appear to meet at a point. That means they are not forming an image, that is they are not meeting really, but they are appearing to meet at a point. And what happens is that suppose there is suppose we see cinema, okay, in the talkies, also in multiplexes we see the movies and all. And what happens is that there is a screen and we can see the film over there. So that is a screen, and behind this screen there is a light coming, there is a projector, we call it as a projector. So from there the image is being projected onto this screen. Okay, so this screen, whenever there is a formation of image on a screen, that is real. Because what is the point is that in case of a screen, when we are putting a screen and we are observing an image on a screen, it means the image will be real. Why? Because we are putting the screen for real. There is a screen which we are putting and we are observing an image over there. So that means that the reflected rays are actually meeting on this screen and forming an image. So that is why we call that real images that can be transferred or that can be taken on a screen. Whenever a real image formation is there, we can tell that these type of images can be taken on screen. Okay, these type of images can be taken on the screen because a screen is a real thing. We are really putting a screen somewhere, and then we are observing some images or some pictures over there on the screen. So that means that the rays which are falling on this screen are actually meeting. That is real image. So that we can understand that these type of images can be taken on the screen, which are real images, and correspondingly this virtual image, that will not be the case because these are appear to come from a point. These are not actually meeting. So if in the last case also, the reflected rays in the real sense were tend to be diverging from each other, so they won't be meeting anywhere in the real space. So that means even if you put a screen anywhere, because you can't put on the back side, that is not the place where you will be putting a screen. And if you are putting a screen, there are no rays there. To our eyes only it is appearing that rays are coming from there and image is forming behind. It's all an illusion to our eyes. There is an image which is virtual, but if you put a screen really over there, at that point where that virtual image was forming, you will not see any image on the screen. Why? Because in actual sense they are not meeting. It is only appearing to our eye that they are meeting. So that is why these type of images cannot be these type of images cannot be taken on a screen. Taken on a screen. So these are the major differentiation between these types of images, that is real and virtual image. One more thing, we have discussed now plane mirror. So we will be taking some of the pointers on this plane mirror because some of the nature of the image is very specific about this plane mirror. Suppose I put an object here and I was seeing that this is your reflect incident ray and this is your another incident ray. Let me correct the diagram. Okay, yeah, fine. This is your incident ray and this was your normal. So this, let us assume this was your normal. And if I draw the reflected ray, this is your reflected ray. For this angle will be equal to this. So somewhere here the reflected ray is coming. So I will project this in the back side. Okay. Like this, somewhere they will be meeting like this. So I told you that this was your object. This was your object. This was your object. And this is the image of the object, which is virtual, obviously. And always a reference is important. Your eye is placed here. We are taking that your eye is placed here. So these rays are entering your eye, but to your eye it feels that these are coming, these rays are coming, these rays are coming from this point. So your eye gets an illusion of an image here at this point. So this is your plane mirror. So one thing specific about plane mirror is that always, as I told you, always anywhere you place this object in front of this mirror, always the image will be forming on the back side of the mirror. We call this as the back side of the mirror. So that means the nature of image, if we talk about nature of image, in this case it will be virtual. For a plane mirror, we are talking about plane mirror. For a plane mirror, the nature of image will be virtual. It will be virtual. Moreover, if you stand in front of a mirror, suppose you are standing in front of a mirror and you are observing this image of your mirror of yours on the mirror, and try to move your left hand. Suppose this is your left hand and you're trying to move this left hand. What happens to your image? You see that the image will move its left hand, but it will you can see that it will be its right hand. That means if you are moving this hand, this image will be moving this hand. If you are moving this hand, the image will be moving this hand. That means if you are moving yours left hand, the image is moving its right hand. See from the perspective of that image. The image which is formed in the mirror, its right hand is moving and yours is left hand. So what you can see that there is a flip also. There is a 180-degree flip, and this is known as lateral inversion. We call this as lateral inversion. Lateral inversion. Lateral inversion means that whatever is left in the real for the image, you will see that its right is getting affected. So that is why this lateral inversion is observed on the plane mirror. And third of all, you can see that when you are standing on the ground and observing your image on the mirror, you can see the image is also standing on the ground. That means it is not 180-degree flipped upside down. It's also erect. You are standing on the ground, the image is also standing on the ground upright. It's not upside down. It's not upside down. It's perfectly in vertical sense, it's perfectly as it is with the object. So this is called erectness, or we call the image is erect. Okay, it's upright. That is called as erect. And the fourth thing about this image is that the distance. Whenever you try to measure the distance, see this is the object distance from the mirror, and the object distance, the distance of the object distance from reflecting surface, we use u as a general terminology, and the image distance we will be calling it as v. So if you take this distance and you take this distance, the distance of the image to the mirror, so this u will be equal to v. This is what the fourth point is, that you can see this for yourself in the mirror also. If you are standing in front of a mirror, you can see that there is some distance between the mirror and you. And if you observe the image is also perfectly equidistant from the object as it is from the mirror. So the distance between the object and the mirror and the image which you are observing, its distance from the mirror, both are equal. That is the point is. The image is also at a distance from the mirror, which in actual sense you are standing from the mirror. That means the object distance and image distance is same. So these 4 pointers are important for the nature of image in case of a plane mirror. And I told you what is a plane mirror, a perfectly reflective surface. A plane mirror is a perfectly reflective surface with no irregularities. That means it must be plane throughout. There must not be, surface should not be like this. It should be like this only. This is your plane mirror. So this is what and how an image is formed on a plane mirror. So because of these 4 pointers, the plane mirrors are used in the some of the applications are based on these type of nature of image only. Suppose for a ambulance, in an ambulance, you can observe that the ambulance letters in front of the vehicle is written from right to left, not in the perfect order. They are not writing it from left to right. They are writing it in the reverse end. They are writing from right to left. So why they are doing so? Because always an ambulance is an emergency vehicle, so it always, maybe the ambulance vehicle needs to reach a, say, a particular hospital or clinic at perfect time. Maybe there is a patient inside. So what is the case is that the vehicles in front of the ambulance must give the proper way to the ambulance to go quickly. So what will happen? The vehicle in front of the ambulance, suppose this is the ambulance and this is the vehicle in front of it. So on its rear view mirror, we can say that there will be lateral inversion. You have understood that there will be lateral inversion. That means the right will appear to as the left and vice versa. That is, left will appear right and right will appear left. So if the ambulance word is written in the reverse order, what will happen on this mirror? This driver can see this ambulance is written in the correct order. That is from left to right. So as soon as he will see that there is an ambulance coming behind, he will give the side. Or also for other mirrors anywhere else, plane mirrors. So what will happen due to this lateral inversion, everyone, because of this reflection, the vehicles in front of it will be able to see this ambulance clearly, and they will give it the proper side. Obviously we can see that the size of the image is also same. Size of the object, we can add one more point here, that size of object is same. Size of object and size of image is same. That means the height of you standing in front of the mirror, the image will be also of the same height. So that is why they are used in general lookup mirrors, because there will be no distortion. There will be no distortion. You will appear as it is, except your this lateral inversion. You will be perfectly appearing as it is, as you are in a plane mirror. That's why these, in general lookup mirror, these mirrors are used. In dressing rooms also these mirrors are used, because they will give you your truest reflection, which is necessary life also, because this plane mirror will give your truest reflection, except this lateral inversion, which has its own uses also, and that is why ambulance is written in the reverse order. So this was all about the plane mirror. So these 4 pointers you must know. 4 to 5 points you must know about the mirror. That is the nature, because this is very heavily asked in many exams. First of all, the image of the nature of image will be virtual, and it will be, what will it will be? It will be erect. That is, it will be straight, and lateral inversion will be there. That means the left will appear as the right. And the fourth point is then the distance of image from the mirror and the distance of object from the mirror, both will be same, and the same size of object and image. That means the object size and image both will be having the same size. So this is what we have learned about reflection today. What is light? We have learned about light. We have learned about reflection, and we have learned about types of reflection also, and we have learned about plane mirrors. Now what we are going to do is we will be extending our discussion to this mirrors. Some mirrors are not perfectly plane, some mirrors are curved also, which we call spherical mirrors, and in the subsequent classes we will be discussing about those. So up till now plane mirror is complete, and we will be discussing about spherical mirrors in the subsequent classes. That's all for today. So thank you.